Hello, everyone. I'm thrilled to introduce Erik Mosselaar, the Sales and Business Development Manager for Distance. And today he's going to be talking about needs-based lubrication scheduling, remote monitoring, automation, edge and cloud analytics. So everything rolled into one. So really looking forward to this. And I just do want to point out, here's the code for this session. So do the play to win for those Apple products. Use this code for the session, and without further ado, let me get you to Erik.
Hello and welcome. Thank you for joining us today. I am going to kick off this session by stating that among the numerous operation and maintenance tasks, several can do with a makeover. Most of these are common, purposeful routine tasks that often come with unwelcome side effects that accumulate to high time waste, resource waste, and environmental impact, and potentially high costs. Today, I address two of these routine tasks, bearing lubrication and oil analysis. In both cases, the waste level is high and the environmental impact can be quite significant. For the first task, we have developed a revolutionary method to turn time-based schedules into need-based ones based on data acquisition with standard accelerometers, automated on-site analysis and enveloping on the edge, and we then visualize this in a simple-to-use dashboard along with various cloud-based tools. For the second task, we integrate smart oil quality, contamination, and color recognition sensors with our system, top these sensor level analyses with more analysis on the edge, and present this in the same user interface, partially with the same tools available. All of this creates an easy and quick workflow for the operations and maintenance professional and offers an extensive remote toolbox for the vibration or lubrication specialist. And additionally, I will address the positive impacts of automated analytics on remote services and expert availability. Hi, I'm Erik. I am a business development manager for Distance, and we hail from Finland. To get us started, I would like to share first a few details about who we are, what it is that we do and why, and how we do all this. Originally, Distance was founded under a different name by the guys behind the Linux system. And we have been doing what we do for industrial OEMs for close to 2 decades now. The first remote vibration monitoring system was developed based on over 4 decades of university research with vibration analyst category 4 specialists and is delivered as a white label since 2006 to monitor the planetary gearbox, main bearing, and generator in wind turbines. In 2016, we decided to pivot and develop Condense under a new company name, and instead of building this from scratch every time, we designed one platform to be sold as a rebrandable white label to OEMs and service providers and as a ready solution for end users. Meanwhile, over 5,000 systems are delivered in more than 40 countries and across various industries. Also good to know, our CEO and my mentor, JP, is actively developing the Maintenance 4.0 models with EFNMS. JP is also a member of the Committee for Remote Services at the ESA. To us, this confirms just how seriously we are taken, at least at a European level. We believe plant reliability must be delivered need-based rather than time-based, and we help change complex and stressful jobs into simple, planned, and organized ones. We aim to eliminate time and resource waste, help turn environmental impact into sustainability, and replace specialist scarcity with availability. We help our clients optimize their operation and maintenance organization and enable precision maintenance for rotating machinery on all criticality levels across the plant. We do this with the help of our prescriptive maintenance platform, Condense. The client benefits from easy and quick workflows to support data-driven decision-making with, for example, actionable labels attached to alarms and notifications. This then forms a reliable first line of defense for asset reliability assurance. It optimizes expert resource distribution and increases the overall effectiveness of MRO teams. For instance, not only can a developing hairline fracture be detected months before becoming a problem, but the exact location can be pinpointed down to the components within the bearing, inner ring, outer ring, ball cage, or whatever. With Condense, the machine calls for a doctor when it needs one and confirms its health status when it doesn't. And when issues do start to develop, it indicates how long it takes before attention is needed. A quick introduction to Condense. Condense primarily targets Tier 2 rotating equipment. Via open sensor interfaces, Condense collects high-quality, near real-time data from any type of rotating machinery on a component level with off-the-shelf commercial sensors for vibration, RPM, oil, pressure, flow, temperature, current, and many more customizable measurements. This data is automatically analyzed and enveloped on-site in an edge terminal with embedded software and is then sent to the cloud via 3G or 4G at 5-minute intervals, where alarms can be configured and prescriptive labels can be added. Additionally, raw data is sent to the cloud once per day, where it remains under the client's ownership and is available for example, remote analysis services. And there, from any computer, tablet, smartphone, the data is accessible in a simple-to-use user interface, and cloud-based tools provide a simple yet effective workflow for the operator. Alarms and notifications are configurable in many different ways and on multiple layers, from standardized templates to highly customizable solutions. After the alarms have been configured entirely up to your specific needs and wishes, you will fully benefit from this clear workflow. For instance, the Cloud Revealer feature provides oversight and helps you to prioritize tasks. And the forecast estimates when an issue will most likely become a problem, 3, 6, or even over 9 months ahead. And then Lubrication Indicator helps our clients grease their machines need-based rather than time-based. And this lubrication indicator relates to the first task that we talk about today. This feature lives inside the advanced terminal, not in the cloud. Traditionally, most bearing lubrication schedules are time-based or based on OEM recommendations. Some drawbacks of these schedules are the risk of undergreasing, the risk of overgreasing, and the potential for time and resource waste, and the unnecessary environmental impact that comes with it. An alternative approach is to monitor the equipment with ultrasound technology, which is a great step away from time-based lubrication scheduling. Condense adds a new dimension to this and enables need-based lubrication schedules based on data acquired by off-the-shelf commercial accelerometers. In collaboration with a Finnish university and based on their earlier research, we have developed a method to make this possible. This is probably an open door I'm kicking in here when I state that acquired data, no matter how accurate, only translates to benefits when analyzed properly. And then still, this depends on what decisions we make based on the analyzed data. Now, to better understand, let's take a closer look at Condense Advanced. We sample acceleration data at 48.9 kilohertz, 24-bit, and can adjust the sample length up to 1 minute at this frequency. Between 1 and 2 minutes, we tune down the 9.7 to 9.7 kilohertz for data storage's sake. And theoretically, if we combine all independent channels, we can go up to nearly 20 minutes, although we haven't seen any use case for this yet. During every calculation cycle, where we look at the data from many different angles, well over 550 calculations and enveloping are automatically executed on site inside the edge terminal. We simply introduced a few new ones to the pile that, instead of on vibration, focus on friction. Simply put, increased friction indicates decreased lubrication effectiveness. So you can probably imagine that from here it's only a small step to create need-based lubrication schedules. And without the need for additional sensors or technology, other than the standard accelerometers and RPM sensors that provide all the other benefits too. On a side note, this is just the first application for this new method. For instance, during the live testing phase at established customer sites, we noticed that it looks like Condense can detect developing failures even 2 to 3 months before they start to show in the enveloping. This has been cross-checked verified in the field against some top brand handheld devices. And then there's more. Optionally, the Condense platform easily integrates with third-party platforms, IT systems, inventory systems, maintenance systems, etc., and has a third-party hardware and cloud interface. This also means that if the user chooses to integrate Condense with their CMMS, the client can then use this signal as a trigger for automated lubrication pods that are connected to the same CMMS. And other alarms and notifications can trigger maintenance tickets on top of the prescriptive labels that can be attached to these. And also remember, this is still done from the same independent platform. But lubrication schedules are not the only time-based ones that could do with a makeover. The way oil sampling is commonly done is another example. Because these are also time-based, this leaves room for blind spots in between the scheduled sampling and while waiting often for about 2 days for lab results to return. This means there is an opportunity for reliability optimization. Other drawbacks here are, for example, a potential time and resource waste and unnecessary environmental impact. How many healthy oil samples are taken and transported to external labs? And then the lab technician spends their time testing and preparing a report. For what? To confirm oil health? Doing this online instead forms a similar first line of defense as the earlier mentioned vibration analysis and other metrics do. Condense Basic taps into specialized measurements like oil and harder to reach places such as submerged installations. This also allows a mix of measurements like oil and vibrations, for example. Commonly, this solution connects several smart sensors to one terminal with analytics on the sensor level, which is then topped with further analyses inside the terminal and in the cloud. The main target groups for Condense Basic is the mid-critical machinery, and some popular uses are for monitoring turbine oil and hydraulic systems, etc. The use of Modbus integrated smart sensors for particle measurements, for chemical properties or oil color recognition provides reassurance of the oil health and means that the asset owner only physically samples when necessary. This is cost effective, this reduces time waste, improves manpower efficiency, and significantly decreases resource waste. And this way, the environmental impact and carbon footprint are further mitigated too. So bringing this all together, Online oil monitoring and analysis can of course be applied to standalone lubrication lines or hydraulic systems, but can also be combined with other measurements for optimal benefit. For instance, quite commonly, condense is used on gearboxes. In addition to the vibration monitoring, drilling down to the component level of the bearing and monitoring the gear mesh, when sudden particle bursts are detected in the lubrication system, this indicates misusage, blockages, etc. And it gives the owner a more accurate insight into possible failure, root cause, and remedy. Because the system is this versatile, the entire drivetrain can be monitored in the same system with the same accuracy. The electric motor is monitored and its bearing lubrication can be scheduled based on lubrication indicator. The gearbox is covered with vibration and oil analysis. And for the driven machine, basically any desirable and relevant metric can be added. Condense has more options available for various process criticality levels. And all this then easily scales across the plant or customer fleet, all within the same platform. We offer you a technological tool set to help you to eliminate time and resource waste and to turn environmental impact into sustainability. With this, complex and often stressful jobs change into simple, planned and organized ones. And this helps you to replace specialist scarcity with availability by allowing remote tasks. In short, your time-based plant reliability schedules are now performed need-based, with rich data as a firm basis for decision-making. This toolbox is simple to use, it's easy to set up, and it is highly cost-effective and scalable. So as said, another issue we'd like to address is that of expert availability. Globally, maintenance managers face a common challenge of expert resource availability. Simultaneously, the productivity of many inspection processes is low due to several reasons. The most common ones being the inspection of healthy machines and the manual design of this process. Using scarce expert resources with non-optimal efficiency leads to limited expert availability with a high cost. The cost of predictive and prescriptive maintenance technology is decreasing, and new technology emerges monthly or even daily. Access to this technology is not an issue. The dilemma for many managers is how to implement this in the daily business. Now, there are a lot of buzzwords around, like digital twins, 5G, anomaly detection, AI, and machine learning, all great, every single one of them. But how do we use these technologies? Where, when, why, and to solve what problem? Adaptation will require a digital transformation of existing processes. We'll provide some insights on how technology service delivery of periodic inspections can be enhanced and better decision-making and overall availability can be stimulated by combining predictive and prescriptive maintenance with remote services and assistance. The purpose of predictive and prescriptive maintenance is to support maintenance teams to automatically manage and monitor the health of a large fleet of machinery on one or multiple sites. Simplifying this process is what we call predictive and prescriptive maintenance. Principally, this is applying new digital tools for existing analog process designs. Local teams are and will always be valuable. However, efficiency increase comes by using reliable technology as the first line of defense. Technology that confirms the health status of the asset fleet. This leads to better task allocation. With the first line of defense now secured by technology, the second line is formed by remote assistance from either a local service partner or a third-party remote expert that can be sourced anywhere on the globe to examine the raw data from the built-in analysis tools, or to extract this data to run additional analyses. And the third line of defense still relies on the field expert. The main difference lies in the efficiency of the expert, who now has more time to focus on what actually needs attention. This also means the client spends fewer resources on the reliability process. And when then eventually it comes to taking action, the efficiency of the maintenance crew increases as well, because they know exactly where to look and when, what spare parts are needed in inventory, and what skills are required, and potentially what is the optimal time to plan action. For the client, this means shorter downtime and less collateral impact to production. Even the daily, for example, preventive maintenance approach gets easier. For instance, as highlighted earlier, by looking at data from different angles, the technology can improve scheduling lubrication intervals as you know how lubricant is performing. In practice, the system can predict when to grease, and you now also know when not to grease. Time-based grease schedules are a thing of the past and can now be replaced with need-based ones. Coming back to solving the expert scarcity issue, besides automizing routine tasks, job execution by local teams can further positively stimulate the distribution of expert knowledge and provides new ways to collaborate with service providers and remote services combined. Local partners not only provide feet on the ground, but also help to build trust and build cultural and lingual gaps. But perhaps most of all, besides being distributed locally, their expertise is available to other global clients in the form of remote support. The aspect of making data-driven decisions leads to more systematic decision-making and understanding how, when, and what is done. When detecting potential and actual issues early and precisely, the optimal time for preparation, planning, and execution is given. This will require the use of systematic data collection with detection tools, built-in actionable suggestions, and tools such as a forecast to evaluate timing and actions needed. One interesting implementation is integrating actual fleet health into risk management and to evaluate the risk of loss when data-driven actions are taken versus if preventive actions are taken versus if nothing is done at all and risk realizes in full glory. RAMS-based tools already are commonly in use. This will guide organizations to take smart managed risks instead of common ones. Furthermore, this type of information should be able to integrate into maintenance management systems and other systems that are built for production optimization and data post-processing. However, many legacy systems have not been built for this and might not even be suitable for effective remote services very easily. In these cases, the maintenance and reliability strategy might need some rethinking to enable such. Some key takeaways today. Technology to minimize time and resource waste, to decrease operation and maintenance costs, reduce stress, and to mitigate your environmental impact is available. There are short-term wins by optimizing the process of preventive and predictive maintenance procedures, on-site and off-site inspections, and in optimizing collaboration with service providers. This will boost the efficiency of resource use and delivers an increase in availability. Prescriptive maintenance can and will make maintenance teams more efficient and precise in the allocation of their activities. And remote services will scale resources and increase their availability. Collaboration with service providers and experience will play an important role in implementation. By proper implementation and strategic partnerships, benefits are certain. The next level is learning from asset data and long-term development. For example, how do we make decisions, how to match risks we are willing to take, and how maintenance links back to quality, sustainability, and productivity. So whether you are an asset owner and will implement this as an end-to-end solution, or you are an OEM and wish to increase after sales under your own brand, prevent warranty issues, or get real-time feedback for your R&D purposes, or maybe you are a service and maintenance provider looking to change your business model from offering traditional maintenance and after sales to a hybrid one, including remote services, to enhance customer intimacy or to improve customer value and profitability. In all these cases, this condensed toolbox is for you. We have the technology at your disposal without R&D investment. And for a white label solution, this is pretty much a plug-and-play business model. All you invest in is in sales and in marketing. And lastly, I want to share with you a few quick examples of partner experiences that directly connect with the previous slide. High ROI and short payback periods, increased effective after-sales and intimate customer experience, and direct and real-time feedback for product design improvements. Thank you all for your attention, and I hope you find what you need and this information is useful for you. Have a great day and enjoy all of the other topics presented by my colleagues at this event. And most of all, many thanks to the Lubrication and Reliability Organization for making this possible and for providing all of us with this wonderful stage to deliver our messages and to extend our offers to help. Thank you. We are here to help. Bye. Have a wonderful day.
Erik, thanks so much. What a great presentation.
It's a bit longish, isn't it?
It's perfect. We're right on time. I think we have time for one question if it's out there. You have, looks like a fan club here. Andy's saying hi.
Yeah, I'm looking at a quite empty inbox otherwise.
That's okay. That means you've answered all the questions. So we're good.
Man.
Do you have any final, 1 minute thoughts to leave us with?
No, I don't. You told me you were full of questions anyway.
If my questions would take you another 20 minutes to answer. So my impressions are it's amazing. So and we've got Christoph saying the same, that
Thank you, Christoph.
it was a great presentation too. So thanks for your time. We're right up on the clock.
Thanks again for the stage.
Hey, thanks, Erik, for spreading the knowledge. Appreciate it. Thank you, everybody.
Cheers.